So the turning effect produced will certainly be FL sine of theta. Okay. You don't need to resolve to get the other because when we check, we still got the same thing. So the force is 150. The length is 20 centimeters. So 0.2, which is 10 times 2 times sine of 110. So you have 30 times sine 110. And this is equal to what? What is 30 times sine 110? Yes. 30 times sine 110.
$28.19.
So give it to me in 1 dp.
28.2.
Newton meter is the torque. Okay, so
Yeah.
hello.
Please, instead of writing 20, wrote 2.
Is that 20.2?
No, the length is 20, the perpendicular distance.
I wrote 2 on 10.
2 on 10, yeah.
So I
Okay.
didn't, I wanted to use,
Sorry.
okay, no, that's fine. So if either the length, then we can also have this situation.
Mr. Dear,
Hello.
please, did you use the formula that was F sine theta times L?
Yes.
So, sir, please, the 20/10, the 20/100, where was it from?
It's the length. 20 centimeter, but I change it to meter.
Oh, okay.
Because I didn't want to use calculator. That's why. Okay.
Okay, thank you.
Welcome. We can also have this situation of as a question.
Hey, good.
And here, this is the length of the rod. But the rod is at an angle of let me draw it this way. The rod is at this angle theta to the pivot. It's at this angle theta to the pivot. And F acts on it this way. You see, look at the difference. Over here, the force was the problem. The force wasn't perpendicularly to it. The length of the rod had no problem. And so we resolved to get a component of this force, okay, which will be perpendicular to the rod, the length of the rod. Over here, the force is not a problem, but the length is a problem. Are we okay? Are we okay?
Yes.
So
Yes, please.
the length L is a problem. The force is not a problem. So all that we do is that we resolve the length, get the component of it, which is perpendicular to this force, multiply, and we get the torque or the turning effect. So this is what happens when one of them is not in line. Okay, when one of them is not in line. And obviously, this is not a problem. If it's about this, then the component that will be perpendicular to this will certainly be L cos of theta. The L cos theta will be perpendicular to the pivot, the force. And so the turning effect, therefore, becomes F times L cos theta. This is FL cos of theta. So that's how this thing is. All right. If you have any question, ask. If you don't have any question, then we continue. Let's look at laws of movement or the principle of movement. Do I clean the board?
Yes.
And please, here too, sometimes they can give you this angle. Instead of this, they can close this and then give you this. And if it's about this angle, okay, then here, yeah, this cell will be a component of L that will be perpendicular. But if you are using this angle, then this part becomes L sine theta. Are we fine?
Yes.
So here, what have they given? They have given you the angle between the length of the rod and then the force, L sine theta. So if you give me this or that, don't let them deceive you. Wherever they take you, you have to catch them. Okay. All right. Principles of movement. Okay, let me quickly give you an example here. Okay, just an example. F is equal to 2,500 Newton. The length is 2 meters. The angle between the force and this is 45 degrees. Determine the turning effect produced by this force. Determine the turning effect produced by the force. No, I've changed the 2 meter to 200 centimeter. The 2 meter is changed to 200 centimeter. Finish. Hello.
Hello.
Yeah, so now I'm coming in. Good morning. Mhm. Okay, finished. Okay, so here, as I said, the length of the bar is a problem. So you find a component which is perpendicular to the force. And because the angle given is this component will be L sine of 45. Okay, so a component Ly would be equal to L's, which is 200 sine of 45. And sine 45 is root 2 on 2. So you have 100 roots of 2 centimeter. When convert this to multiply this by, okay, this is root 2 is 1.414. So times 100, 141 centimeter, which will be equal to 1.41 meter. Okay. So the torque will therefore be equal to 2,500 times 1.41 or 414. And that will be equal to what? That will be equal to hey, are they still around?
Yeah.
Uh,
3535.
I'm coming. I want to confirm it true. This is 3535. Good. 35 Newton meter. So, and it isn't anything difficult. Okay. Principles of moment. Principle of moment. If you have a rigid bar like this, supported on a ninth edge or a pivot. Now, if supposing you have this force acting at the ends, F1, F2. Then the pivot, for this to be at a state of equilibrium, for the bar, to be at a state of equilibrium, then the sum of the forces acting in all directions must be 0. So for the bar of length L to be at equilibrium, then all that we are saying is that then the sum of the forces acting in all directions must be equal to 0. Or we say that the net force F net, then F net must be equal to 0. The net force acting on the body must be equal to 0. What it then means is that, look, we have these two forces, F1 and F2, acting downward. So Adwa is sitting here, Sanam is sitting here. Okay. Now, for this to be stationary, to be at rest, no moving vertically, then the pivot, the knife edge on which the bar rests, would have to produce a force in the opposite direction to balance these two forces. So this is what we term as a reactional force. The pivot would have to produce a reactional force R in the opposite direction of the two forces to balance it. So all that we are saying is that at equilibrium, or for a position of rest to be attained, then the sum of upward forces must be equal to the sum of downward forces. Sum of downward forces, or summation upward must be equal to summation downward. So for equilibrium states to be obtained, then R, which is the reactional force, must be equal to F1 plus F2. And this is the first principle of moment. This is the first principle of moment. So how do we build bridges? You see, in building a bridge, if this is the road, there's a support here, there's a support at the other end. All that we are saying is that irrespective of the weight of vehicles, that plow the road. Okay. The total weight of the vehicles. The total weight of each vehicle. I know whether it's a Pragia, a Buboya, or whatever. The total weight of them must balance the reactional forces produced. So whether it's an articulator, track, whatever, this condition must hold that for equilibrium states to be obtained, the total weight of whichever vehicle that plows on the bridge must be balanced by the reactional forces produced by the support at both ends. If you don't meet this condition, the bridge will just cave in and the effects, Abi, you know that. Okay. So that concept, this principle of equilibrium state is factored in building bridges, flyovers, overhead, and whatever. No matter whatever passes on the road, when we sum up the total weight, it should be balanced by the supports given to it. If you don't meet this condition, the bodies would have to accelerate vertically downwards, and the effect is huge. So that's the first principle of moment. Any question? Any question? No question.
So, sir, please, I have a question.
Ask your question.
Sir, please, so when you're asked to like just state the law, how will you state it?
One,
Will you
what is the condition? The condition is that is at equilibrium state or at equilibrium, the sum of upward forces acting, acting on a bar, or the sum of upward forces must be equal to the sum of downward forces. All right.
Yes, please, thank you.
Or simply at equilibrium, the net force acting on a body must be equal to 0. Okay. If I should clean this, I said R must be equal to this. So if I have R minus F1 plus F2, what am I to calculate for? Or what am I calculating for? This is the net between R and this. And if it's 0, then the system is at equilibrium. Meaning, it means that the net force is equal to 0. So either you state it as this: at equilibrium, sum of upward forces must be equal to the sum of downward forces, or at equilibrium, the net force acting at a point must be equal to 0. Right?
Yes.
All right. 2. The second principle of moment. If I have this, now I'm not considering the reactional force produced by this. I'm considering 2 forces acting around the bar or around the pivot. The distance from the force 1 to the pivot is A. The distance from the force 2 to the pivot is B. For equilibrium state, you see, what is this direction of the force? This is in this direction. Which direction is this? If this force is in this, what direction? This is anti-clockwise, right? Please, you see it? This direction is anti-clockwise.
Clockwise.
And this direction is clockwise. Okay. Now, for equilibrium state, if I calculate the turning effect, the moment, okay, produced by F1, the turning effect, the moment of F1, or the turning effect produced by F1 is equal to F1 times the perpendicular distance, which is A. Then the turning effect or moment produced by F2 is also F2 times B. Please use it. But which direction is this turning effect produced by F2? This is clockwise. Which direction is the turning effect produced by F1? Anti-clockwise. Okay, so for equilibrium states to be obtained, for equilibrium, the sum of clockwise moments must be equal to the sum of anti-clockwise moments. Or this moment is also said to be torque. So clockwise torque or clockwise torque must be equal to anti-clockwise torque, or the net torque, must be equal to what? Or net torque must be equal to, hey, you girls are asleep. Oh. Anita, Sanam, Adwa.
I'm here.
Or the net torque must be equal to what? Zero. Must be equal to zero. The net turning effect around the pivot must be equal to zero for equilibrium. And this is the second principle of moment. Okay, at equilibrium state, the sum of clockwise moments is equal to the sum of anti-clockwise moments, or the torque, sum of the torque in one direction must be equal to the torque in the opposite direction. Any question? Any question? Now, you see, the illustration I made or I gave on the board uses only single forces. So to fit, Eliana, are you there?
Yes, please.
Hey, you girls are tired. So F1,
Yes, please.
we'll finish soon, don't worry. You see, I use one forces, so it means clockwise. This is anti-clockwise. We have anti-clockwise moment. Is equal to clockwise moment. Here, we cannot use sum because we only have one. In a case where you have more than, as in, we have this force over here, F3. We have this one, F3 is at a distance of C from the pivot. Then we also have F4. The distance from the pivot to F4 is D. Okay, so here you identify all the clockwise movements and all the anti-clockwise movements and then sum them up. So exercise, Sanam.
Mr. Idia.
Help
Yes.
identify the sum of clockwise movements. Help me identify the sum of clockwise movements.
So please, the first one will be F2 times B.
So F2 times B.
And so please, the ones on top, which one is 3 and which one is 4?
This is 3, F3, and this is F4.
So this plus F3 times C.
Plus F3 times C, meaning you mean F3 is in this direction, all right?
Yeah.
Adwa, or Adwa is asleep. Okay, so because Adwa is asleep, let me get somebody to call. You are tired. Abina Yabwa. Abina.
Yes, sir.
The sum of anti-clockwise movements. Help me identify the sum of anti-clockwise movements.
F1
F1 times
times
A
plus
plus
F4 times B.
Good. So, because here you have a number of turning effect around, you qualify to say that Anita, your hand is up.
Yeah.
So please, how you identify which one is clockwise and which one is anti-clockwise?
And the arrows. Anita, the arrows. Look, F1 is acting downwards. Okay. So if this is there's the bar, and I have a force acting on this bar downwards, then it will turn this in this direction around the pivot, right? Right?
Yes.
If it is F2, my hand represents the pivot. The direction of F2 is downwards, meaning the turning effect would go, this is clockwise. Okay. So that's how to identify clockwise and anti-clockwise. Are you okay?
Yes, please.
All right. So because we have,
Yeah.
hello.
The moment of F4 is F4 times B, not
F4 times is B, yes. Abraham, good. You can see mistakes. Okay, so here, because we have about 2, then we can confidently say that the sum of clockwise moments must be equal to the sum of anti-clockwise movement for equilibrium to be obtained or for equilibrium states to be achieved. Is that okay? Or the net moment around the pivot is equal to 0, okay, for equilibrium. So this is the 2 main principles or laws of movement. Any question? Any question? So this brings discussion to an end. Today, this evening, in fact, those colleagues of yours who were not able to come this morning will be taking through the same thing. So you can absent or you can be present, okay? Because basically we'll be doing the same thing. All right. So until we meet again, possibly tomorrow or on Wednesday, take care of yourselves and then revise. Okay. All right. So bye-bye to all of you.
Bye.
You are already tired, so